Energy can neither be created nor destroyed. We often hear such true but abstract statements from physicists. To make sense of this fundamental concept in physics and of everyday items like ACs, we need to understand the difference between heat and temperature. As we know, a body is made up of many small particles. These are constantly vibrating, so they possess kinetic energy, which is simply energy by virtue of motion. The greater the vibration, the more energy the particle has. They also have potential energy due to their subatomic structure. If we add up these energies for every particle in a body, we get heat energy of that body. However, if we look at the average kinetic energy of the particles, we get its temperature. Temperature determines the flow of heat. That is, a body with a higher temperature loses heat when in contact with one with a lower temperature. We can take two glasses of water, one at 20 degrees and the other at 60 degrees. When they are mixed together, their temperature will average out to 40 degrees. However, that is only the case when the mass of the water in both the glasses is equal. If we add a glass of 60-degree water to a bucket of 20-degree water, then the resultant temperature will be closer to 60 degrees. This shows us that during heat transfer, the mass of the bodies involved plays a big role. We can make one more observation in our daily lives. Say we put a pot of water on the stove to heat it up. This can take quite a bit of time. After 10 to 15 minutes, the water might reach its boiling point of 100 degrees C. Then we dip a large metal ladle into the water with a similar mass to that of our water. It will heat naturally and the heat will be transferred to the ladle. However, the metal ladle does not take 10 to 15 minutes to heat up. In fact, it should not take much than a minute. So our ladle gained heat much quicker than our water. This property of different substances heating up at different rates is called specific heat capacity. That is the amount of heat required to raise the temperature of a unit mass of a substance by 1 Kelvin. In our observations, water required a large amount of heat to increase its temperature, showing that it has a high specific heat capacity, whereas the metal spoon heated up quickly and didn't require much energy, showing a low specific heat capacity. Thus, we have seen that in a heat transfer, the quantity of heat that is transferred from one body to another is dependent on its mass, the difference in temperature, and the specific heat capacities of the bodies involved. Now we can open our formula books and make sense of the formula Q equals mc delta T.